In this video, we're going to cover arrays, the insert command, and how to get a little help in updating inside of the database. So, first thing, of course, and probably this will be the last time I do this, make sure that your server is up and running. If you needed to take a snapshot, go right ahead. Make sure you have a window like this and minimize both of them because we will no longer be using them. And then open up Terminal. I like making it nice and big. And then run the SSH command to access the box. And again, your password is ADB. Okay, so in this lesson, we're going to talk about arrays. And one of the big innovations in databases is arrays. You've worked with arrays in C#. You've worked with arrays in other languages as well. Pretty much every programming language can have an array, at least today. However, if you recall in MySQL and relational databases, there are no arrays. There were strings, there were integers or numeric fields, there were date fields, and then there were nulls. And that's pretty much all there was. There's a couple of other fields like text fields, which would be strings, or decimals versus integers, which would still be numerics. But there were no arrays. It was all one field held one piece of data. In Mongo, we can do something different. We can go ahead and create a record, and I'm going to give it an ID of 1. And we're going to say that here Mark Zuckerberg is a client. His age is 28. And here's a new one. His favorite numbers are 1, 3, 5, 7, and 11. And this is an array that, just like any array, can be empty, can have one value, can have these 5 values, or can have 1,000 values. I have a little cheat sheet here where I'm going to copy and paste from to make this video go a little bit quicker. But I'm going to go ahead and start up Mongo. And now I'm going to paste in that x equals and this Mark Zuckerberg record. When I'm done, I'm going to say db.test.save. Now here's the interesting thing. If we do show collections, well, I'm sorry, we didn't start attached to a database yet. So let's go ahead and say use ADB. Always have to do that when you connect. And now let's type show collections. And here is our user collection, location, and courses. So I'm going to go ahead. We already created x as a local variable. Now I'm going to say db.test.save, and let's save x. Interesting thing. We never actually created the collection, did we? We never said that there was a collection called test. However, if I go and I rerun show collections, there's the test collection. Tables need to be created ahead of time in the relational database world. In non-relational, at least in Mongo, you just say db.test, and Mongo will say, well, if it doesn't exist, just create it on the fly. So now we have a new collection here called test. So if I do db.test.find, there's that new Mark Zuckerberg record with his favorite numbers in here. Okay, so arrays are a bit of a new coming feature or new feature in databases. But we can do a little bit more than just do an array of strings, or perhaps we did an array of integers like we did here. We can create arrays of objects. So we have a client named Ben Forda. His age is 58. And you see here these square brackets. That designates it's an array. So the children array has a name of Sally, age 4, and then a name of Jimmy, age 12. And we could put as many of these documents in here. If you think about it, if this was a relational database, we would have to have 2 tables or some type of foreign key relation to say, okay, here's the parent, and then link it over to the children. Because a person can have no children, 1 children, or 20 children. So we can't really go ahead and say child 1, child 2, child 3 like we decided back in the database course. But we can go ahead and create an array. So I'm going to copy that, paste it, and then I'm going to go ahead and type the save command, db.test dot save x. Now I do want to go ahead and actually interrupt here and show you something. If I go ahead and I type in db.test.save and I leave off the last parenthesis and hit enter, what we get is 3 dots. 3 dots means we've opened either a parenthesis, a squiggly bracket, maybe an array. We've opened something, even a quote, but we haven't closed it yet. Now, right now I can easily say that this is a parenthesis. So all I have to do is type it and hit enter, and it will run the statement. However, if you ever get to these 3 dots and you don't know what to type, or it's a long statement, you don't know where the beginning and the end is, and you just want to get out of it, hit enter 2 more times, and it will abort the statement. It will not run it, and it will go ahead and return you to the prompt without an error. So right now, I'm going to add a pretty on here. In our test collection, we should have 2 records, Mark Zuckerberg and Ben Forta. And Ben Forta, you see here, has 2 documents for children, Sally and Jimmy. Okay. Well, that makes things a little more convenient. We don't have to link things to other tables. But this can go a little out of control. Now we have John Winchester, who has 3 children. And rather than look at it here, I'm going to copy it and paste it. And now, you see how it formats it so nicely. We have John Winchester. Here is the child array. And he has a child named Sam, age 14. But now we have an array of Sam's favorite movies: Star Wars, Armageddon, and Total Recall. And here's Dean with his favorite movies, and Adam with his favorite movies. So a question should be, how deep should we go? And usually, unless there's a good reason, this is about as deep as we should go. And what do I mean by deep? Technically, couldn't we make this, instead of just saying Star Wars, in other words, favorite movie is an array of strings, couldn't we make that an array of objects? And maybe in there have Star Wars, he gives it a 3-star rating, and maybe go even further and then say comments. And in there he has different comments on the movie as he reviews the movie. So we can store arrays, inside of objects, inside of arrays, and so on and so forth. There's no set limit, but the deeper it goes, the harder it is to navigate these documents. So we usually want to keep it down to 2 levels, meaning I have an array of objects and maybe another array in there of just flat values. When I say flat value, I mean not another array or another object, something on the order of a string or an integer. So let me db.test.save this. And just to be sure, I'm going to go ahead and run that find and make sure, yep, we have 3 records in here. Mark, Ben, and John. Now navigating these arrays is something we're going to have to go ahead and play with. But right now I want to go ahead and talk about the insert command, because insert is a little different than the save command. Last week we were working with the save command, and save was both an insert and an overwrite, meaning if I go ahead and I'm going to say something like this, 1, 2, 3, 4, and then I'm going to do something ridiculous, like instead of being an array, I'm going to change this to banana, and over here, instead of doing insert, I hit save, and save. Let's see what happens. Well, the first time I run the save command, it will go ahead and save it. And if I run a find command, and right now we're going to filter, I'm going to say I only want to find where the ID is 0. There is the document we just saved. Now if I go ahead and run another command, T-O-D-A-Y, and I do a save command, and in fact I'm going to leave out description. I'm going to call this comment. So now I'm running the command with the ID of 0. I'm going to save it, but I don't have a description I have a comment, and prime here is an array, but prime here is a string. What's going to happen is save is always going to overwrite the entire record. So it says, oh, we already have an ID of 0 existing here. So when I ran this save command, it just took these fields, all the fields, dropped them, got rid of them, and overwrote it with the new fields. So now we have comment and prime as banana. However, the other way to do it is using something called an insert. And an insert works the same as an update, except it will never overwrite. So now that I'm going to do an ID of 0, the insert should say, wait, an ID of 0 already exists, don't do the overwrite. And there we go. We get a duplicate key error. Normally I use insert over save most of the time, but let's do this. Let's delete that record. So I'm going to say db.test.remove, and let's remove where the ID is a 0. Now I'm going to go ahead and run the insert. Now the ID of 0 no longer exists, so the insert succeeds. Now if I run the insert a second time, the insert fails because it already exists. So again, the rule is, if the ID field exists and you're doing an insert, error. If the ID field doesn't exist, or if the ID field is not passed in, then we create a new one. So insert is a lot safer to use than using save. Save will overwrite the record. However, there are more functions in Mungo. Last week we learned how to do an update using find1. So if I wanted to go ahead and update where the ID is 0, I would say x equals db.test.find1 with a capital O, and I would say where the ID is a 0. And it would come back with this, and I'd say, okay, x dot name is equal to something. And that would save it locally. And if I type x, it attached name now to that object. So I could do db.test.save x, and because x overwrites, the ID of 0 already exists. Now it's saved, and if I do my find here, again, find from the database, the name is on there. Again, this is one way to do the update. There's a much easier way to do it. It's using the update command. Now I'm going to say db.test.update. Now the update, just like when you updated stuff in SQL, has two parts to it. The first part here is the ID, meaning that's the where. So we're going to say on the test collection, do an update to the record where ID is 0. This is a where. So we're going to do that same thing, and I'm going to say where the ID is a 0. Now the second argument is what are we updating? And if I go over here and say prime 1, this is going to do something somewhat unexpected. The update is going to act as an overwrite. And we're going to fix that in a minute. But right now, ideally, what we think it should do is take prime and make it a 1. Now, what it actually does is remove all the other fields. It dropped description and it dropped name. And it said, oh, prime is 1, and overwrote it, and that's that. Ideally, that's not what we want to do. We want to be able to update a single field and leave the rest of the record intact. So we need to always use this set command. So let's fix this record. I want to go ahead and say db.test.update, and I'm still going to update where the ID is a 0. And I'm going to say $set : And you don't need these extra spaces. I like them there just because it's more visual for me. Now, if I go say, let's set the description equal to prime numbers. This time, it left prime by itself and only touched the description field. It added the field. Well, besides doing that type of update, where we add a field, we can also update a field. So let's do this. Let's take this prime, and let's set prime here back to an array. And in the array, let's put those values back. So 2, 3, 5, 7, 11, 13, 17, and 19. And as you can see, what happened was it left description alone and only updated the prime field. So, as a rule of thumb, whenever you do an update command, you should always be using the set or some other feature onto it. Otherwise, it just acts as a overwrite and overwrites the whole record. So let's go ahead and make a even more detailed change. This lesson is on arrays. As you can see here, this, number 2, is not really a prime number. But if you don't know, prime numbers are numbers divisible by themselves or by 1. So technically 2 is not a prime number, 4 isn't a prime number. They're numbers like 3, 5, 7. If you don't know, don't worry about it. But I want to go ahead and make an update. I want to change this value to a 1. Well, I'm going to go ahead and go back to my update command here. So db.test.update. We're still going to update where the ID is 0, so I know what record I'm going to update, what document. And I'm still going to do a set, but over here, I'm going to put in quotes prime.0. What this means is go to the prime array, and the 0 means get the first element. In this case, it's 0 is the first element, 1 is the second element, 2 is the third element. Now take that element and set it equal to 1. Here's a note. When you are using this dot notation, meaning field dot position, you must put it in single quotes. Now if I run this, and now I run my select again, you notice I updated at position 1 and we changed that 2 to a 1. So we can go into an array and update a single value. Like let's go ahead and say I don't want 17 for some reason. This is where we're going off the trails. Let's see, 17 is the 0, 1, 2, 3, 4, 5, 6 position. So I'll say dot 6, and I'm going to change 17 to 911, just for fun. I know, but fun is relative. And now you'll see here we updated from 17 to 911. So we're able to update by giving the actual position inside of the array. We can also do some other ways of updating it. You hear this term upsert. Basically what it means is if we do a update but the record doesn't exist, turn it into an insert. So if we were to go ahead and run a query and run an update, and we set the upsert to true, but nothing matched the query details, like let's say we were looking for, let's do this. I'm going to do an update. I'm going to go ahead and just set the prime to 911, but I'm going to say the ID is 11. If you notice, we get 0, 0, 0. Why? ID 11 does not exist. If I go ahead and I do a find, let's see, yep. I have my ID of 0, 3, 2, and 1. There is no 11. However, if I was to add on a third argument here and say upsert is true, UPSERT colon true. Well, if I spell it right, SERT. Invalid property. Oh, I have my parentheses off. That should go there. If you look, that matches up over here. And then I have an extra one over here. There we go. And what we'll see now is n upserted is 1. So there's our record 11. So if you ever want to add a record or you're issuing an update and you're saying if that record doesn't already exist, create it. You could add on a third argument to your update statement, which says upsert. There's lots of little features like this in Mongo. Like this one. Multi is true. By default, if I run an update statement, it will only update one record at a time. If you wish to update every record, like let's say it's a game and you're resetting everyone's score to a 0, you need to go ahead and do that. So let's do a quick example. Here's an update, and I'm going to start off with the blank. I'm going to do this. That means update every record. And what I want to do is set score to a 0. Now if I run that, it only updated one record, even though obviously that means every record. Let's take a look. No score here, no score here. Let's go all the way to the top. The first record has a score. So if I want to go ahead and update every record with a score, what I need to do is at the end here, say multi is true. Now it tells me 5 records were inserted or matched and 4 records were modified. So now everyone has a score. Again, you have a little bit more control than you do in SQL. You have a little bit more options in SQL, or different options at least. Okay, so if there's a set, there's an unset. So if I want to go ahead and remove score from here, I could do db.test.update, and I'm going to update where the ID is 11. And over here, I'm going to say $, unset, and inside of unset, I give it the field name. I'm going to say score, :1. The 1 doesn't mean anything. The 1 is just a placeholder here. You could go ahead and say the 1, and instead of 1, putting in quotes, banana cream pie. It won't make any difference. It will still go ahead and just unset that value. So if I do that, and then I do my find again, we see that on 11, that was removed. And again, that was from running the unset command and told it to remove the score. So we can either set or unset fields on individual documents. We can also go ahead and increment. So let's do this. Let's do db.test.update. And I'm going to create a new value. So I'm going to say where the ID is 0. I want to set, and I want to set the counter field equal to 1. And I'm just going to modify this find to say where the ID is a 0. Okay, so now we have a counter field of 1. There's a command to either increment or decrement that field. So over here, instead of saying set, I'm going to say inc. And what this means is update where the ID is 0, increment the counter value by 1. This is no longer a placeholder, it is an actual value. If I run that now, the counter became 2. So the question everyone says is, well, what if I make this 11? Well, 11 plus 2 is going to be 13. and the counter is 13. If you want to decrement values, instead of using a positive, just use a negative. So minus 3. 13 minus 3, our counter should now be 10. And there's our 10. So we can increment or decrement using the update command. Let's see, there are many ways we can, remove. Let's skip this for a moment. We're not going to remove the document where the ID is 0, because right now we already have the ID of 0 with all of these values in here. We're just going to keep working with those. We can do stuff working with arrays like push or pull. And I'm going to go ahead and look at this array here. And I'm going to modify this, bring it down to its root, update. So we're still going to update where the ID is 0. But after 19, I want to add 21 to this. So what I can say is $push. And I'm going to push onto prime. And what I want to push onto prime is the value 23. So it added to the end of there 23. I can run this statement multiple times. And when I do and I can push 23 multiple times, even though it's the same value, it lets me do it. Besides doing a push, there is another command called push all. The difference between push and push all is push takes one element and pushes it to the system, to the document. Push all is going to accept an array of documents. So instead of just saying 23, I can say let's push 100, 123, 191, and 187. 97. Let's make it 87. Now what this is going to do is instead of pushing an entire array onto here, it's going to loop through all these values. So now we end up with all of these on here. The question I usually get at this point is, well, what happens if I pass an array to push? Well, an interesting thing happens here. Onto the prime array, we've pushed another value, which is an array of more numbers. Yes, Mongo will accept arrays of arrays. So that's probably not what we wanted to do, but it is possible. Mongo will let us do that. Okay, besides push, there is pop. In the pop system, the pop feature, the 1 is another placeholder. So I'm going to go ahead and remove this down to here. Make this pop. And I'm going to pop from the prime array. And just for fun, I'll put a 213 here just to show you. It's just a placeholder. It's still going to pop off the last value. And what you'll see is the last value from the prime array is gone. You cannot, and if I run it again, we see the last value here is 187. Now it's 191. Pop always pops from the end of the array. There's no other way to use pop except grab it off the end. Next one is pull. Pull does the same thing as pop, but it does it actually by value. So over here, this is not a placeholder. It's actually a value. So let's do this. I'll remove all of that. I say $pull. And let's pull 911 from here because it doesn't belong. It's right in the middle there. So what pull will do, sorry, got ahead of myself. We need to pull from the prime array 911. Oop. And now 911 is taken out. So pull is a way to target specific values. One thing I do want to show you is that if I do a pull on 23, we have 3 occurrences of 23. Pull means kill all of them. So now if I run this, and then I do my find again, you notice we lost all three values of 23. So know when you do a pull, it pulls all the values, occurrences of that value. Besides pull, there's a pull all that works the same way. So if I'm looking to remove multiple numbers or multiple values or strings or anything from an array, I could say let's pull 5 and 13 and 123. And what that will do is modify the array, and all of those values are gone. So there's plenty of ways to manipulate arrays with push, pop, pull, pull all, push all. That's pretty much it for arrays, I think, for the most part. There's a few other things I want to show you. One is distinct. So I'm going to switch over to, from the test, over to the database collection, the user collection. So if I say db.user.distinct, well, distinct does the same thing it did in SQL. We pass it a value like user type, and it says, well, the unique values in user type are client, administrator, lowercase client, overlord, and admin. Remember, it is case sensitive. There will be some places where distinct comes into handy. Eventually, we'll learn how to do for loops with Mongo. But right now, just know that distinct works the same in SQL as it does in Mongo. Lastly, indexing. And you're probably asking, but this is supposed to be on arrays. Well, you can actually index arrays as well as regular values in Mongo. So if you want to check to see what exists, we'll do db. Actually, we'll use, let's use user. Dot get index keys. And what this says is the ID, underscore ID, is a ascending array. Obviously, just like in SQL, primary keys automatically get indexed. If we want to go ahead and get more detail, you could say get indexes. And this gives you some more information. If this was maybe a compound index, it would show you multiple columns. But essentially, indexes work the same in Mongo as they do in SQL. But let's create an index. Let's say db.user.createIndex. And I'm going to say I want a last name index. And 1 means ascending. But in Mongo, you can actually do a -1. And this is starting to become available in non-relational databases and relational databases. What that means is it creates the index in reverse. So imagine going to the index of a book and the Z's are on top. Why would we do this? Well, what if you index something like created date, and you were always querying by created date, and you were always looking at maybe the last hour or day or week worth of info? Well, instead of having to go through the entire index, the most recent info would be on the top of the index. So it's just a way of reversing it. But right now, let's just say a 1. And it comes back, and I'm going to rerun that get index keys. And now we have an ID field indexed and a last name field indexed. If you want to create a unique index, you have to add on there unique is true. And I would run this, but I know it's going to error out because my data here is not totally sound. Some of the usernames are repetitive. But if you add on to the end, unique is true, that will make that a unique index, which means if you try to insert the same value twice into that username field, it would error out. Last thing on indexes is reindex. Reindex essentially drops and recreates your indexes. Not in that order. It actually recreates the indexes and then drops the old index and points everything to the new index. So why would we want to go ahead and drop and recreate an index? Well, over time, if you run on a database where a lot of updates occur, the indexes may become fragmented, which means they're written on different parts of your drive. Essentially, what it means is your indexes actually start going slower because it takes more time to load them. Reindexing, again, it's not something you will do if it's just you on the system, unless you're running some really intense queries. But something like Amazon, or even something much smaller, banking software. If you have 1 million rows or more in a table, you probably want to reindex it at least daily maybe weekly. And all that's going to do is drop and recreate them, and it keeps running, it polishes the indexes and makes them run faster. And the final last thing I want to tell you about is the help features. Mongo has done an exceptional job of providing help. On their website, there is quite a bit of help. If you ever need to look at something, type MongoDB space and whatever your topic is. Usually go to the Google it and then go ahead and follow the link to the Mongo page. But they also embedded it in the database. So if you want to type help, you get a bunch of help commands. Stuff like if you forget what show DBS or show collections, eventually we'll do show users and a couple of other information. But this is only part of it. If I go ahead and say I want help on the DB commands, I can say db.help, and that's a function. And these commands are more stuff like, we haven't learned these, but we will, authorize, clone database, copy database, drop database, previous error. These are more database commands, repair database, reset error. We'll get into a bunch of these later on. The stuff that you're doing now, you could do db.test, any collection name will do, .help. And this will go ahead and show you how to do stuff like, oh, how do I get my indexes? Or how do I do an insert? Or later on we'll find aggregates, or your save command. Here's a little spec on your update command and the different options available. So they made a really good effort to put as much help in as many different places as possible. So that concludes this lesson, and I hope this was helpful.